So today topic is silicates. So this topic is a very easy topic. The questions will be asked from this topic. So there are 7 types of silicates we have. The first one is ortho. This is also called as nesosilicate. The second one is pyro, and this is also called as sorosilicate. The third one is chain cycle silicates, and this is also called as pyroxenes. And the fourth one is ring or cyclic. Fifth one is double chain. This is also called as amphiboles. And the sixth one is sheet or phyllosilicates. The seventh one is three-dimensional. This is also called as tectosilicates. So among all these seven, these four are very important. These five are very important. Ortho and pyro, these are not that important because these two are very easy to remember and there is no much confusion. Whereas there will be confusion between chain silicates and chain silicates as well as ring silicates. So it's very simple. I will be explaining in details so that it will be easy. So first I will come from the ortho. The first one is the ortho. So in orthosilicates, each silicon atom is surrounded by the 4 oxygen atoms tetrahedrally. Okay, like this. Okay, so this is called orthosilicate. The unit which we have is SiO4 4 minus. So this is the unit we have for orthosilicates. Okay, next the pyrosilicates. The joining of these two units of orthosilicate by single oxygen atom called as a pyrosilicate. So here we'll take another orthosilicate, and this time this silicon will form a bond with this. Okay, so this is called as the pyrosilicate. So pyrosilicate general formula is Si2O7 6 minus. So in the examination point of view, there may be a question that which of the following silicates shares one oxygen atom at one corner. So the answer will be the pyrosilicates. Okay, so these two are very easy to remember, and these two, there will be a lot of confusion between the ring silicate and chain silicate. Just remember, chain means linear. We see like any chain, so that will be linear shape. Okay, ring means cyclic shape. This we can call as a ring, like that. Okay, for these two, the molecular the general units which we have is SiO3 N to N minus. So this is the unit which we have for cyclic as well as a ring silicates. And for cyclic silicate we have this kind of form. So this is just like this. So in middle silicon will be there, and these are the oxygens. These are the oxygens. Okay, for each unit we can see, if you take this unit, so how many oxygen atoms are shared between each unit? This is 1, this is 2. So you can take any unit, so there is a 2 oxygen atoms are shared. 2 oxygen atoms are shared between oxygen atoms are shared by each unit. Okay, with another unit. So this is about the chain silicate. And ring silicate also same, but it exists in the ring form like this. So this is a, this dot in middle one is a silicon atom. So this is the example for ring silicate. And here also we can see, if we take this unit, how many oxygen atoms are shared? 1 and 2. And if we take this unit, how many oxygen atoms are shared? 1, 2. If we take this one, 1 and 2. So each unit are shared by shared 2 oxygen atoms with other units. So that is called as a ring silicate. The cyclic silicates means in the linear form, ring silicates means cyclic forms. So then we'll go for the double chain. This is also called as a amphiboles. So amphiboles. The general formula of amphiboles is Si4O11 N 6N minus. Okay, so for amphiboles we have two types of tetrahedrons, two types of tetrahedra. Means all silicates are which are present in the tetrahedral shape only, but for amphiboles we have two types of tetrahedron. So one tetrahedra shares 3 vertices, and another one shares 2 vertices. So vertices is nothing but oxygen atoms. So if we see the structure, so amphibole structure, if you want to draw the amphibole structure, just draw the 2 cyclohexane rings connected by 1 carbon. Okay, now here one triangle, then another triangle, another triangle, another triangle, like this. Like this. Okay, and now we'll keep a oxygen atoms. So this is the structure of amphiboles, and here we have 2 vertices, which is means one oxygen is shared by 3 vertices, another oxygen is shared by 2 vertices. And if we see these vertices, and here we have a 2 oxygen atoms are shared, 2 oxygen atoms are shared, and we'll take when we see this vertices here, 3 oxygen atoms are shared. So in case of amphiboles, there are 2 types of tetrahedra. For the first one is three vertices, the second one is 3 vertices. Okay, this is about the amphiboles. And then we have a sheet silicates. Sheet or pyrosilicates. The general formula of sheet and pyrosilicate is Si2O5 N minus 2N. Okay, this is the formula of sheet silicate. So here this is the the general formula. Here means the structure will be drawn like this. These cyclohexane rings are connected like this, and here one vertices will come, and then this way. this way. So here the actually it's not proper structure. I will be drawing here. So this will be vertices here. Okay, like this. So here we have a oxygen atoms. So this is forming a this is a three-dimensional sheet, and here each SiO4 tetrahedron shares 3 oxygen atoms. So everywhere we have a 3 oxygen atoms are shared. So here we can draw the structure. So like this will be like this. So this is the two-dimensional. This is the two-dimensional. This is about the sheet silicate, and the last one is the tectosilicate. Tectosilicate is a three-dimensional silicate. Here the general formula we have is SiO2N, and in examination point of view they will be asking a number of oxygen atoms, number of silicon atoms. So to remember that one, so I will be telling one small indication, small thing we can remember. Thus just remember this statement: the champion champion rams openly, so people dance. Okay, so here take number of silicons, number of silicon atoms, number of oxygen atoms. Okay, so now it's like just keep 4 ones, and here 2 and 2 twos are 4. Okay, now this 1 plus 1, how much? 1 plus 1 2. This you just remember 2. Now 1 plus 2 3, and here C means cyclic, R means ring. So I have already said that the only difference between cyclic and ring is the pattern. So cyclic is the sheet one, ring one is the cyclic one. And now 1 3, and O means like 1 plus 3 4, then 1 plus 4 5, 5 plus 2 7, 7 plus 4 11. Okay, so T means tectosilicate or three-dimensional silicate, C means cyclic or pyroxenes, R means ring or cyclic. So this is chain, sorry, this is chain. And O means orthosilicates, S means sheet silicate, P means pyrosilicates, D means double silicates or amphiboles. So if you can remember this, the champion rams openly, so people dance. If you can remember this one, if you can remember this pattern, so whatever silicate they will ask, and it's very easy to predict a number of silicon atoms and number of oxygen atoms. So I hope you like my video. If you like my video, please subscribe to my channel, and also share this video to your friends. Thank you.